In 1859, the sky over the Caribbean turned red. Telegraph operators felt electric shocks through their equipment. Paper on their desks began to discolor from the heat of the sparks. Something had reached the Earth from a distance of 150 million kilometers. No war, no weapon, just light, magnetism, and a star that has burned above us for billions of years. This is the story of the sun's temper, and why every few generations it reminds us who's really in charge. On September 1st, 1859, British astronomer Richard Carrington sat in his observatory sketching sunspots, as he did every other day. But that morning, he saw something no one had ever recorded before. A blinding white flash of light that flickered across the sun's surface for a few minutes. In that moment, he didn't know what he was witnessing. No one did. But the answer arrived faster than anyone expected. Within just 17 hours, normally such an event takes several days, a wave of charged particles struck Earth's magnetic field. The sky practically exploded in color. Auroras, usually only visible near the poles, were observed as far as Cuba, Hawaii, and even Colombia. Gold miners in the Rocky Mountains woke up in the middle of the night because the sky was glowing so brightly they thought morning had come. At the same time, the high technology of the era collapsed. Telegraph systems. In Europe and North America, sparks jumped from the equipment. Some technicians reported electric shocks when touching their devices. And most astonishing of all, some lines kept working even after being completely disconnected from power, driven purely by the storm's own energy. It became known as the Carrington Event, to this day the strongest geomagnetic storm on record. And ever since, scientists have asked an uncomfortable question. What would happen if this repeated today, in a world entirely dependent on satellites, power grids, GPS, and the internet? May 2024, the storm of our time. We didn't have to wait long for a preview. In May 2024, astronomers observed an unusually active region on the sun's surface, larger than the entire planet Jupiter. Within a few days, it unleashed a whole series of powerful coronal mass ejections into space. Massive clouds of solar plasma, each one heavier than anything humans have ever built. When these clouds reached Earth, they merged into a single, massive impact. The result, the strongest geomagnetic storm in over 200 years. And this time, the whole world witnessed it. Auroras glowed far beyond their usual range, visible as far as Florida, Mexico, North Africa, and even the Caribbean. Millions of people who had never seen the northern lights in their lives stepped outside that night and looked up at a sky shimmering in green, pink, and violet. For many, it was far more than an astronomical event. It was personal. Families lay down in the grass in the middle of the night just to look up. Strangers spoke to each other on the street simply because they were witnessing the same wonder. For a few hours, the entire planet became aware, all at once, that we don't live isolated in space, but directly within the reach of a star. How a solar storm actually works. So what's actually happening up there? The sun is not a calm, evenly burning ball of light. It's restless, unpredictable, almost alive. It constantly releases a stream of charged particles, the solar wind. But on its surface, magnetic field lines repeatedly tangle, stretching like rubber bands, until they suddenly snap, releasing enormous amounts of energy. This is called a solar flare. Often, something even bigger follows, a coronal mass ejection, or CME. This literally hurls billions of tons of plasma into space at millions of kilometers per hour. Like a gigantic, invisible cannon shot, aimed or simply by chance toward Earth. When such a CME hits our planet, It collides with the magnetosphere, the invisible magnetic field surrounding Earth like a bubble. This exact collision creates auroras. The charged particles are guided along magnetic field lines toward the poles, where they strike oxygen and nitrogen atoms in the atmosphere and make them glow, like a giant natural neon sign in the sky. Normally, this magnetic field protects us reliably. It safely deflects most of that energy around the planet, like an invisible umbrella. But this shield isn't always equally strong. The weakening field. Scientists have observed for decades that Earth's magnetic field is slowly changing. On average, it's growing somewhat weaker globally, and in some places, it's even shifting noticeably. Particularly notable is a region over South America and the South Atlantic, known as the South Atlantic Anomaly. There, the magnetic field is measurably thinner than elsewhere on Earth. Important to understand, this is a natural, well-documented process. It's caused by the movement of liquid, molten iron deep within Earth's core, a process that has been ongoing for billions of years, and is what gives Earth its magnetic field in the first place. It doesn't mean the shield will disappear soon. Magnetic fields have shifted, weakened, and even completely reversed polarity countless times throughout Earth's history. But it also means, in some regions, the shield is thinner today than it was 200 years ago. And that's exactly why space agencies like America's NOAA monitor solar activity so closely. Because a weaker magnetic field, combined with a strong enough solar storm, could mean that effects, like disruptions to satellites, power grids, or radio communications, become noticeable farther from the poles than they used to be. What some people believe: the solar flash idea. Events like these have, over time, also inspired something beyond pure science. In some spiritual and esoteric circles, people speak of a coming solar flash, a moment of exceptionally intense solar energy that some believe could not only affect technical systems, but also trigger a profound shift in human consciousness. Some connect this idea to the body's energy centers, the so-called chakras, and to the notion of a collective spiritual awakening. Here, it's important to be very clear. This is a belief, not a scientific prediction. There is no evidence in solar physics that a solar event could directly alter human consciousness. What scientists can predict with high confidence are electromagnetic effects on technology, power grids, satellites, radio communications. Everything beyond that remains unproven speculation. And still, it's worth understanding why this idea resonates with so many people. Because moments like May 2024, when the entire night sky suddenly turned to color, feel to many people like something beyond pure physics. They feel like a message, like a reminder that we are part of something much bigger. Whether you understand this as faith, as spirituality, or simply as pure awe at a glowing sky, the feeling behind it is real and deeply human. Even if the scientific mechanism behind it is, in the end, simply plasma, magnetism, and physics. The sun has been speaking to us for as long as we've existed, sometimes in quiet, warm light that makes our lives possible in the first place, and sometimes in powerful storms that travel 150 million kilometers just to remind us that we were never separate from it. We live, quite literally, within its outer atmosphere. Next time, we'll look even deeper, into the sun itself, into its hidden core, where all of its power actually begins.